The goal of this part of the lesson is just to look over how to do the practice problems. So if you're ever feeling stuck on any of the odd ones, or if you just want a little more practice with how to go through things, this is what this recording is for. All right, here we go. On this first problem, you'll notice it's multiple choice. That's because graphing this by hand is actually kind of tricky. And so most of the time we'll use a graphing calculator, either the handheld or Desmos. On your power assignment, you're likely going to see here the multiple choice version, so let's get some practice there. Here's what you need to know. You're always going to be given information about the y-intercept and the rate of change. And it's those numbers there that I've circled. The coefficient in front, so the number that doesn't have the x as the exponent, that's your y-intercept. So right away, we can narrow our choices down. As I look at these graphs, the graph should cross the y-axis at a height of 1/3. So let's see. We're counting by twos here, so I don't know, that could be reasonable, that could be reasonable, that could be reasonable. This is way too high. Notice this graph crosses the y-axis at about a height of 3. So I can eliminate that choice right away. Next up, I'm looking at the rate of change. So let's first do the easy narrow down. If this number, so if I'm looking at y equals ab to the x, a is what gave me the y-intercept, b is what determines if we have growth or if we have decay. So if b is greater than 1, then we have growth. If b is between 0 and 1, then we have decay. So this b here is 3. That means I'm looking for growth. So this graph shows decay. This graph shows decay. This has to be the one that we're after, letter D. Now, not a bad idea just to do a check. So pick a couple of nice ordered pairs. So for example, we know 0, 1/3. That's an ordered pair we've already checked. Let's put in a 1 for the x. So if I do that, I'm going to have a third times 3 to the first. 3 to the first is just 3. 3 times a third is 1. So my graph should go through the ordered pair 1, 1. Well, 1, 1 would be right about there. I don't know. Seems reasonable to me. Let's check one or two more. How about one more? Let's go to x equals 2. So this time it would be a third times 3 to the second power. Just putting a 2 in for that x. Remember your order of operations, exponent first. So 3 to the second is 9. 9 times a third, it's 9 divided by 3, so 3. So the ordered pair 2, 3. And sure enough, it's exactly halfway between 2 and 4 vertically. Yeah, graph D, that's the one we're after. Okay, let's go again. How about here? Let's narrow things down a little bit. I noticed that this graph has to be a decay graph because the b value, the base of the exponential, is between 0 and 1. Well, this makes it pretty easy then, because that's growth, and that's growth. It's got to be this one. This is the only one that shows decay. Let's do a couple other checks, though, just to be sure. So notice here in front, that should be my y-intercept. Does graph D cross the y-axis at a height of 3? Sure looks like it does. And then I think that's all I want to do here. We check the y-intercept, we check the growth or decay. A lot of times that's all you need with these multiple choices. Okay, next up. I'm going to give myself a little extra room here. Okay, let's take a look first at growth and decay. So this is 1/6, that's between 0 and 1, so a decay graph. So A is decay, so is C and D. B isn't, so we know it's not going to be B. Now the leading coefficient, I've got a 1/2 in front. This is my y-intercept. Now this is hard to estimate because we're counting here by twos. So each mark on the y-axis represents 2. That means a half is only going to be about a quarter of the way through. I don't know. Could that be Maybe I'm not ready to cross it off as an option yet. Here, this maybe looks a little closer, but again, I'm not ready to cross it off as an option yet. This one, though, that very clearly crosses the y-axis at 4. That's not a half. That's too high. So we can eliminate choice D. So it's down to either A or C. Let's now get more specific and check some ordered pairs. We know that when x is 0, the y-intercept ended up being a half. Now, because this is decay, it's probably going to be easier to look at a negative exponent and see what comes out. So down here, let's think a little bit. So a half times 1/6 the negative first power. You must remember what negative exponents do. They take your fraction, they flip it upside down. So really what I want is 1/6 flipped upside down to 6/1 and then raised to the first power. So I use the negative to flip my fraction, and now we just need to simplify this. Well, 6 to the first is just 6, half of 6 is 3. So I'm looking for the graph that goes through the ordered pair -1, 3. This first graph, -1, 3 would be right about there. Nope, this first graph does not go through that point. Let's hope that this one does. So -1, 3 will be right about there. That looks good. So notice on this one, it wasn't just enough to look at the decay and estimate the y-intercept. You had to actually check another point to be sure. That's always a possibility. Next up, here we go. Let's do the same thing. So I'd see this has got to be exponential growth because this 5 is bigger than 1. So that's decay, that's decay. The other two, though, are growth. Okay. Y-intercept at 1/4. I don't know. That could be a fourth. I don't know. That could be a fourth. So once again, we're going to have to check another point, maybe even two, and we'll see, to figure out what's going on. How about we make our lives a little easier? Let's pick a nice number. So how about a fourth? We're going to complete the ordered pair 1, something. So a fourth times 5 to the first power. Well, that's just 5 times a fourth is 5/4. As a decimal, that's 1.25. Okay, so I'm going to put here 1, 5/4, and let's see. So 1 5/4 would be 1. I don't know. It's hard to estimate, right? This one maybe looks like it goes through 1, 2. That would be a little bit high. This one here maybe looks to go through about 1, 1.25. It's still hard to tell. So I think because the grid lines here are counting by 2s, let's do another one. Let's evaluate the ordered pair that starts with 2, and forgive me, I'm running out of room here, and see what comes out the other side. So let's think about this down here. That'd be a fourth times 5 to the second. 5 to the second is 25. 25 divided by 4 is about, 6.25. So just a little bit past 6. So here's what we're looking for. I want to see when x is 2, is the graph just a little bit past 6? Well, this first graph goes to 6, 8, 10, 12. It's all the way up at like 12 or 14. This sure looks to be too high. I'm going to cross that out. And this one down here at 2 is about 2, 4, 6, right around or maybe a little bit past 6. Yeah, that's where we want to be. So it got a little tricky, right? Still start in the same place. Check for growth or decay, narrow it down. Look at the y-intercept in front, narrow it down. But then after that, check some ordered pairs until you find a graph that very clearly matches up with the one you're looking for. Hey, now the reverse. This time we're shown the graph. We need to find the equation. We're going to do the same thing. I'm going to first say, all right, I know it's going to fit this format. I know that this number in front is the y-intercept. So on your graph, look where you cross the y-axis. That's at a height of 4. I also know that because this is a growth graph, this number is going to be bigger than 1. So let's take a look here. Well, right away, we know what the answer's got to be, right? This is the only one that has a 4 as that front multiplier. But let's not just stop there. I want to make sure we know where this number is coming from. It's all about picking another point on the graph, like this one. And frankly, if you can get the point that's at x equals 1, that's always going to be the easiest. So let's do that here. This is the ordered pair 1, 8. So to find this number, we're going to come down here and think a little bit. I know that if I'm using this model, and if I know y is 8, x is 1, and the a value we already found is 4, let's put those numbers where they go. Well, b to the first power, that's just b. Divide both sides by 4, and that's where we get this b equals 2 coming from. So can you see why I said if you can use the exponent of 1, it's always easiest? It's because b to the first power is just b. You don't have to worry about powers anymore. Now, if you have to use an exponent of a 2 or a 3 or even sometimes a negative number, it's okay. We can still do it. It's just a little easier if you use the power of 1. Okay, next up. So let's see here. We see growth. So I know that my b has to be greater than 1. My y-intercept, it's a little hard to estimate. Looks to be about halfway between 0 and 1, so somewhere around a half. Let's take a look at the options we have and narrow it down. So it's got to be growth. So this number less than 1 to the x, not going to be that. Number less than 1 to the x, that's decay. So it's one of these two. Well, the y-intercept very clearly is not at 2. So it's not going to be letter D. That means B is the one we're after. Once again, though, just for practice, we're going to make sure we know where that 6 is coming from. So let's pick the ordered pair at 1 if we can. All right, it looks to be about there. Okay, that is 1 over, and 1, 2, 3 spots up, so 1, 3. Now let's do what we did back here. If I know the y is 3, the a we think is about a half, and because we already know what the answer is, we know it's exactly a half. And then the b to the first, since the x is the 1 right there. That means 3 is equal to a half times b. B to the first is just b. Now, whenever you've got a fraction times your b, just multiply by the reciprocal. So by 2 over 1, which is just 2. And then 1's reduced, 2's reduced, just the b is left behind, and the 6. Okay, that's where the 6 right there is coming from. Okay, now with these last two, you'll notice it is not multiple choice anymore. That is not an accident. We're going to need to write the whole equation ourselves this time. Okay, let's follow our pattern. Start with the y-intercept. It's right there. That's at 2, 4, 5. So a is 5. Now, to get this b value, because your final answer has to have a number for the a and a number for the b, we're going to need to find another ordered pair that's kind of nice. So, I don't know. I don't think I want to use this one because that's not at a nice intersection of gray grid lines. Actually, none of these are. What you're going to find is that with exponential decay, it's usually easier to go to the left. So as I go back here, this is actually a pretty nice ordered pair, right? At -1, 10. So here we go. Let's put the 10 in for the y. We know the a in front is 5. The b is the number we don't know, and we're using an x value of -1. Here's what I recommend. Because if it's b to the first, that usually turned out pretty easy. You could just leave it as b. But here, I want to save this. I'm going to save this for the very end, and you'll see why. Let's get this by itself. It's currently multiplied by 5, so how about I divide by 5? That'll give me 2 equals b to the negative 1. Now, when you're looking to get rid of exponents, in the past, if you've had an exponent of 2, you can do a square root. If you've got an exponent of, say, a negative 1, then the best way to do it is to raise both sides to the power of negative 1. Let's see why. Over here, how much is negative 1 times negative 1? Well, that's just b to the first. Over here, 2 to the negative 1, remember what a negative exponent does. It flips your 2 upside down, and then the exponent of 1 just stays exponent of 1 there. Well, b to the first is just b. A half to the first is just a half, and just like that, you've now got your b value. So give it a look. Y equals 5 times 1/2 to the x power. And then if I were you, last thing I would do is pull up a Desmos, graph it, and look at it. So I think my answer is y equals 5 times 1/2 to the, to the x power. It goes through 0, 5, and goes through negative 110. We're in good shape. We are in good shape. Okay, one more. The exponential growth ones, they tend to be a little easier because you don't have to do this last little trick we did. Now, notice the reason that we raised to the negative 1 power again is because those exponents get multiplied, and I'm trying to make an exponent of 1. That's why we did that. Okay, let's look at this one then. Starting out the same way. Look at my y-intercept. That's at 2, so my a value is 2. Okay, pick another nice point. If I can, I want to use it where x equals 1. And indeed, we can this time. So at x equals 1, y is 4. So let's put the 4 in for the y. That's 2 times b to the first. All right, b to the first is just b. Divide by the 2. And now we've got everything we need. So final answer, y equals 2 for the a. The b also happened to be 2. That happens sometimes. And then I would recommend giving it a final check with the Desmos graph. Now, just real quickly, let's imagine that you picked a different ordered pair. So we're done. If you're comfortable with this, you can even stop the video. But let's imagine instead of picking this ordered pair, you picked, I'll do it in a different color here. Let's imagine you picked this one. So what I would have instead is 8 equals, then we had 2 times b to the second power. Guess what? We're going to end up in the same place. It's just going to take an extra step. I want to get this by itself, just like we did over here. So divide by that 2. I've got 4 equals b to the second. The trickier thing is that when you've got now a b to the second, I think you've done this before in a class. If you haven't, here's how you get rid of an exponent of 2. That's what a square root is for. So square root of b to the second, that's just b. Square root of 4, that gives you your 2. And notice we end up in the same spot. So you don't have to pick the ordered pair where x equals 1. I only like to pick it because it makes things easier.